Okay, guys, this is our section 6.6, and this is the last of the lessons for this short chapter, the chapter on sequences. In this section 6.6, we're going to review the two previous lessons we've had, and also take a look at one more thing, which I think is quite simple, as you see. So I'm going to take a look at these two concepts. This first concept is what we've been doing in the last two lessons, explicit rule, or in other words, the nth term rule, okay? And today we will be doing the recursive rule. And I guess it is important that you remember what we've been doing so far. In section 4.6, we did arithmetic sequences. And remember that we eventually found out that whenever I want to know the value of a given term, what I have to do is I take the first term and I add or subtract the common difference multiplied by n minus 1 times. And you might just see some of the examples we did during those lessons to remember. That is the main concept we had to learn in section 4.6. Also, in section 6.5, and you might remember that from the previous video, we learned a little bit about geometric sequences. And about geometric sequences, we learned that if I wanted to know a given term of the sequence, what I had to do was taking the first term again, and I would multiply it by the common ratio. This time is the common multiplier factor, and I'm going to multiply it n minus 1 times until I find out what the term is. And these are the two explicit rules we've learned so far. Now, in this section 6.6, we are going to learn something about the recursive rule, and it's pretty much what happens, what I have to do in order to know what the next term is. You can see the summary here: recursive equation for an arithmetic sequence and recursive equation for a geometric sequence. Let's just understand what they are as I do some of the examples, okay? Probably the best way to do that is looking at exercises 7 and 8. I want to know what is going on with number 7. And I want to analyze the a sub n terms. Probably you might say, well, it seems like it's multiplying by something that is less than 1 because this is decreasing every time. Well, it happens that this common ratio is 1/3. Remember, if it's hard for you to recognize it, to identify it, what you can do is just take one of the terms and then divide it by the previous term. In this case, I might take 36 divided by 108. If you simplify this fraction, you will get 1/3. Although if you do it in a calculator, you will get 0.3 repeatedly. But I think it's better to express it in terms of a fraction. So now I identified what the common ratio is, which, by the way, this is a geometric sequence. And then what happens is that if I want to generate a next term here, which means the 5th term, I'm just going to do a multiplication by 1/3. In this case, it's going to be 4, and so on. So the recursive rule, meaning a sub n, I want to know the next term by what should I do to the previous term. And I want you to understand this. When I am referring to a sub n minus 1, I am referring to the previous term. And in this specific situation, number 7, what is happening is that I am taking the previous term and I am multiplying by 1/3 every time. I'm giving you an example, and I just did it, but I'm going to express it in the right notation. I wanted to find out what a sub 5 is. Okay, I'm going to take a sub 4 and I'm going to times it by 1/3. That's what happens. And you see the correlation here? That's what it is. So let's do the same thing with exercise number 8. As you can notice, it seems like we are now dealing with not a geometric sequence. There is no common ratio. Instead, it seems like the new terms are being generated by adding 5 every single time. So if I wanted to know the 5th term by knowing what the 4th term is, I know it's just going to be pretty much adding 5. So I would say a sub 5 is a sub 4 plus 5, as you can see. But I want to give it in general terms, so I'm going to do this. A given term, and in order to generate that given term, I'm going to take the previous term and I'm going to add 5 to it. That is the recursive rule for this, and the one you have here, you see here, is the recursive rule for this sequence. So that's what the recursive rule is about. It's quite simple, as you can see, okay? And that's all we need to know. Now, there might be some other exercises that make it a little bit harder. So let's take a look at exercises 14, 15, 16 and see what happens here. Well, let's do number 15, and we are asked to write the explicit rule based on the recursive rule. Okay, let me try to find out the first 4 terms here. So we have our first term is given here. So the first term is 6. How can I know the next term? Can you see that I take the previous term and I add 11? So in order to find A2, I'm just going to take 6 plus 11. And that is going to be 17. 17 plus 11 is going to be 28. And 28 plus 11 is going to be 39. Now, I have the opportunity to find out what the, in this case, common difference is, which is the plus 11. And with that, I can now do the explicit rule. The explicit rule for this is a given term is going to take the first term of the sequence, which is 6. You can see it here. And I'm going to add how much? 11 multiplied n minus 1 times. That's the explicit rule based on the information we had here. What happens with 16? Kind of like similar, right? So let's do this. A1, A2, A3, A4. The first term, -1. And every time we're going to multiply by 5. So -1 times 5 is -5. -5 times 5 is -25. And -25 times 5 is -125. Based on this, we know that the common ratio is multiplication by 5. The first term is -1, so the explicit rule for this sequence is the first term, -1, and I'm going to multiply it by 5 n minus 1 times. And that's it. Okay? Let's do 17. Because you might find some of the exercises on the Big Ideas Math assignment kind of like that. This should not be really different from what we should know. A1, A2, A3, A4. In this case, n is going to represent the position of the term. So a sub 1 is going to be this. Let me do it over here. A sub 1 is 6 times 1 plus 2, which means this is 6 plus 2 equals 8. So a sub 1 is 8. Now A2 is 6 multiplied by 2. Please pay attention to this, okay? for the second term, and then add 2. And this is 12 plus 2 equals 14. So the next term is 14. Now with that, I can realize that this term here, 6 multiplied by m, turns into our d, or common difference. So it's easier for me to figure out what happens later. We are going to add 6 every single time. Just look at this, and it has this a similar structure to the linear functions. So there's a 26 here, and now I can write the recursive rule for this. In this case, I take a sub 1 is, I am going to take the previous term and I'm going to add 6 each time to generate a new term. And that's it. Now, there may be other exercises that are a little bit harder. I want you to look at them. And I guess this is part of your notes, maybe not. So I'm just going to show you what happens here. Look at this. These ones are really interesting because I'm taking the 2 previous terms and adding them. You might see any kind of combination, subtracting, multiplying, I don't know, different things. How can I generate new terms here? Well, I am going to look at a sub 3, according to this, should be a sub n minus 1, which is a sub 2 plus a sub 1. In this case, a sub 3 is 1 plus 1. So there's a 2 here. Now, a4 should be a3 plus a2. So in this case, we would have 2 plus 1, and that's a 3. Then a5, it would be a4 plus a3. In this case, we have 3 plus 2. That's a 5. a6 is a5 and a plus a4. Now you're getting this. 5 plus 3 equals 8. This is 8, and then 5 and 8 is 13, and 8 and 13 will be 21. And I like this one. Why don't you take a look at some videos? You will have time today. Snow day, you know. The Fibonacci sequence. And try to YouTube something like Fibonacci sequence in nature. And you tell me what you discover. It's something really interesting, guys. It will be entertaining. I can promise. Hopefully, for most of you. You won't be disappointed, okay? This is a special kind of sequence. It's called the Fibonacci sequence. Okay, take a look at how the Fibonacci sequence shows up in nature. Starting from really, really small things to really, really big things in nature. All right, so this is all I have for you today. Make sure that you work on your big ideas math assignments. You keep working on your packet as well to help you practice. Next time we meet, hopefully, if there is no snow, we'll have the chance to do a test review. And the session after that, which means it's going to be next week, we'll have a test for this brief and short chapter on sequences. Okay, I'll be on my email. Just feel free to write me, and if you have any questions,